Okay, so let's start. Um, my name is Ola Gasidlo. I'm a developer for more than 10 years now. I'm the co-member of Hoodie and co-organizer of Open Tech School Conference and Reject.js Twitter misprinted type. And thank you for having me. I'm super excited about that. So let's start. Not much time. Today I will tell you what the offline first concept actually is and why we need that so badly, where the problems occur on the client and on the server side. How we as developers, we have to rethink our application logic, and I will show you one way to implement the concept because there are a lot, but yeah, I will show you one. So, offline first is like the new cool kid in town, but what does offline first actually mean and why do we need it? The internet. It turned 25 last year. In this time, our relationship with the internet, it changed a lot. We do different things with different devices than like 25, 10, 5 years ago. And it's a part of our everyday life. So to wake you up a little bit, I will ask you some questions and just raise your hands. Who of you use their phone today for more than 5 different tasks? More than 10? More than 15? You're addicted. We rely on our devices, on the internet, but our needs changed. Like you see here, we've reached the turning point. Since last year, there are more mobile than desktop users out there. In some countries, there are just mobile-only users, like in Egypt, for example, just to make sure there's no desktop device usage at all. It might surprise you, but think about it. Mobile devices are much cheaper than a laptop, for example. And for many people, this is totally enough, considering what they're actually using their devices for. So, to wake you up a little bit more, because it's early, again, some questions. Raise your hands. Who of you ever tried to work on a train or a plane? How well did that go? Who of you ever did a screenshot of the applications because they were too scared of losing their data? You're right. And who of you ever stood like in a supermarket and wanted to ask someone because you forgot what to buy, like a friend, someone from the family, and realized, damn, I'm offline. Happens to me all the time. What if your traffic limit is reached? Your hotel Wi-Fi is way too expensive, or the roaming costs are like not reasonable. Those are issues we all know even from the wealthy countries we live in. Today, our work, our whole social interactions, our lives are built on being online. When you're not online, it almost seems that you don't even exist. We need new ways to deal with these issues and be able to stay a part of the online community and stay in touch with our friends and our families. And the situation is way worse in the rural areas with poor or even no network coverage. Zero reception, unreliable and inconsistent connections are still an issue, no matter where we go. We need to accept that technology has reached the limits. Go away from the desktop mindset of a permanent and fast connectivity by accepting that being offline, it's not a bug, it's just a recurring state. And let's start and design applications with keeping offline first in mind. There are already some really great applications, offline first applications and services out there, starting with emails, which send the emails when we write, when you're online again. Writing down notes during meetings with Minutes.io or creating lists with CreateList helps us to stay productive without sending error messages as soon as our internet connection is lost. Sending pictures, tweets, messages during a concert. Ever done that? It's really hard and gets tricky when everyone is doing that at the exact same time. Applications like Twitter, they store at least our messages, which is great, so they're not lost. But why not sending it when we're online again? WhatsApp Sync works here pretty well, at least on Android, I heard yesterday. So I see really great applications in the future. Google Maps already implemented some of the stuff, which is super amazing. Like imagine you're in an area you've never been before, and I'm sure we'd love to explore that, right? So What if your application would realize you're somewhere you've never been before, enough space on your device, would realize, okay, I have Wi-Fi, I will download the map for you and show you like the sightseeing points, the next bar or cafe with Wi-Fi, or the nearby ATM, which we all need. It would kind of help you to feel like almost at home. So this sounds great, but what are the real problems here? Let's compare. Mobile first is a design strategy that helps cope you with the huge variety of devices and capabilities like you see here. In the same way, offline first is a design strategy to help you cope with unknowable circumstances and connection states your user might find themselves in. Offline first is simply the acknowledgement that the lack of certainty extends a bit further than we previously thought. With an offline mode, isn't only a contingency for an error scenario, but a fundamentally more flexible, fault-tolerant way of application design. Offline is more than just error handling. It's about accepting the reoccurring state. So we have to ask ourselves, does the application even need to inform the user of the current connection state? Is this information even relevant for the user? And if so, how can this best be done? Like you see here, we don't have an internet connection on Instagram. How can this be a good practice? Why not showing the user data we saved in the cache or stored locally? All the old data can be valuable to the user. Build trust. Can I give the user more trust in my application and leaving them safe in the knowledge that it won't forget the last state I was in and that it won't lose any data regardless of the connectivity situation? So they don't need to think about making screenshots of their applications. And how can I communicate to the human that creating data within the application is still possible and that it will be posted, dispatched, and dealt properly with in the future? This is one of the concepts for the save icon I really love for a new one. There's the unsaved state, the saving cycle with several options, and the save state. And this is how it works. You see the icon in the upper right corner? Yeah. The user types something, the state gets changed to unchanged, then it gets updated and saved again automatically. And this looks like a really good practice to me. Organize data. How can my interface convey changes that occur in the user's current view when they reconnect and the server pushes new and changed data? What to do with deleted items, things that can't be organized in lists, or objects that aren't immutable in themselves, like emails? How can I make the unavoidable resolution of conflicts for the human as painless and as intuitive as possible? This is an error message. My data hasn't been stored. I got that. But this won't help anyone. It's great that I at least know that my data hasn't been saved. But what now? Doing this all over again? I would drop. I wouldn't do that. And finally, decide. Can the application make any preferred decisions of the part of the human and preload any data they might need later? What metrics, possibly behavioral, are there to base these decisions on? And how can I word all of the scenarios in a way that doesn't worry the user, that embraces offline as a reality without causing problems? These are the issues we know from the user side we have to think about. But what does this mean for the server and the client behavior? So traditionally, the server is like the source of truth. The client was always just like a prophet. It communicates always with the server, sends requests, waited for answers, and told the server everything that happened. And when the server is not available, the client panicked, was helpless, and didn't know what to do. When we want to post some data, the client sends out requests and waited for answers. The data was stored, the view was rendered, and reloaded again. So with an async request, the client at least was on call and didn't need to wait all the time for the server. A step forward, but still it was on call. So let's make the client independent. Times has changed and so the internet, and empowered us and also the client. So with offline first, we want to decouple this relationship. But how shall we deal with the new states, and what are actually the new states? A scenario we all know. Imagine you're in a restaurant. The client is the guest and would love to order some food and enjoy the dinner. The kitchen is the server. The kitchen knows all the recipes, ingredients, prepares all the foods for the guests. The waiter gets the request, serves the responses, independent if it's a success or something failed. So as we know the concept, it works like this. The client decides on a dish, orders. The waiter serves the request to the kitchen processes the requests. Server gets back result. Here would be a well-prepared dish. Or the kitchen might be on fire. Well, so the waiter would get back and tell the guest, something failed. Sounds familiar, right? Good. With offline first, it's like the guest would be at home and not the restaurant. With all the ingredients and recipes needs to be stored at home. When the person, so the client decides on the dish, they can look it up and cook it by themselves. This works for all the ingredients which are available and recipes that are known. But what if the person decides to try something new? As a passionate cook, the person needs to ask for the recipe first. The kitchen loves sharing the knowledge. Open source, yay! So the waiter gets the recipe, gives it to the person who can actually start to cook right away because they realized, hey, all ingredients there, awesome. So offline first means you can basically cook at home anything you want. It just works. But for anything totally new, we need to send out a request. And here are the new scenarios. The waiter is not available, so the request will fail right away. The waiter, but what then? Storing the draft, making a queue and trying to send it again, like 1, 2, 5, 10 seconds, again, and annoying the waiter, blocking the request, showing an error, or just ignoring it and make it disappear like it never happened. Another scenario. A part of the recipe makes it back, but not all of it, because the waiter has so much to do that they need to rush back to the restaurant. So person couldn't understand all of it. So should the person cook just half of the recipe and see if it's enough for a good meal? Just don't cook it all? Cook as far as possible and try to call the waiter again from time to time? Can the person change the request for the recipe while he waits because craving for wheat got replaced by craving for beans? And how will the waiter proceed with the new request? How can we keep the frustration level as low as possible? While the guest is making a request, like asking for the recipe, the interface here, the interaction between the person and the waiter should start by showing the process of unspecified duration has started, usually done with this. Who loves that? You can enjoy it a bit. Yeah, annoying, I know. Based on the different error scenarios, the user interface needs to account for the fact that the request failed immediately, or after a timeout, or only a partial response was received. Timeouts needs to be chosen in a way that is useful to the end user. What do you think is a common default on interfaces? What a timeout? Just raise your hand and say a number. What do you think is a common default? Come on, just take a guess. Shout, I don't mind. In real life, like 30 seconds. Okay, something else? 10 seconds, something else. Okay, it's a minute. It's seriously a minute. So, would you wait that long? And always remember, when it's time for more than a second, you have to keep the user busy. Preload images, load data step by step if it's available, and so on and so on. And in case of a timeout, there should be a user interface afforded for canceling the operation, so that the user can apply a shorter timeout if it makes sense to the situation. And partial responses can be super tricky, but still very useful. For example, starting to show, Emma, shh, danke. Showing to start like the top half of the web page, or an email, or other messages. The time it takes the user to read through that might be enough time to like fetch the rest of the data. Sometimes there's not even enough data provided to do anything at all, and the user interface should at least account for that. So we'll see. The offline first concept, super important. We have to rethink how we concept and build applications. So how can we implement that? We need a new approach. We talked about before, like decoupling the client and the server side. And I show you one way the Hoodie team came up with. Hoodie is an open source and free JavaScript library. It offers you like the whole backend with user accounts, storage, shares, emails. It's offline first, including PouchDB and automatic sync, and has a Dreamcode API every developer understands in a second. Hoodie abstracts away all the boring boilerplate stuff you don't want to think about. So let's take a look at the architecture. Therefore, we have like 3 stages. We have the application, then we have the Hoodie layer. Here we use Hoodie Store. The application only ever talks to the Hoodie API, never ever directly to the server-side code, to the database, or not even to the in-browser storage. Feel free to replace the local storage here with any in-browser storage of your choice. This by itself should be enough for an application. Then we have the sync layer, RESTful layer, and the database. We can do that because each user has their own private database. By default, they only can access. So we can't share data by accident. And this is very simple for us to decide what gets synced and how to handle changed data. So I will show you, like I explained to you, a direct message moving through the system. You create a message in the application and send it to the Hoodie layer. The Hoodie layer sends out a task to the local storage so the message can be stored locally and resolved with a promise. At the exact same time, it sends out the same task to the sync layer. When the device is online again, sync layer pushes the message to the CouchDB. It gets stored and tasks are sent out to other devices to update the clients because we changed some data. And the plugin gets the task to send the message. So the main point here is that the client and the server, they never, ever speak directly to each other. They only leave each other tasks and messages. And this all very loose coupled and event-based, which means it can be interrupted at any stage without breaking. And messages and tasks will be delivered and acted upon whenever possible. It's designed for eventual contingency. And if you want true offline capability, your app can never ever talk directly to the server, only through sync, and always you want to keep a local copy in your browser. And sync is really hard. It's super hard. Don't try to do that by yourself, but there's a lot of stuff you can use. So let's talk about the implementation. We have to take care of 2 things, which we store on our devices: files and data. Let's take a first look at the files, because without files, no application and no data. So, who of you ever heard about the app manifest? Who's using it? Who's loving it? No one. The manifest gives you the possibility to fetch the files you'd love to load from the cache when you're offline. I won't go any further here because it's super easy. A lot of tutorials around. Just one thing you need to know here is that appcache is a huge douchebag. A very huge. I'm working with that like 4 years now, and it sucks. A very great article by Jake Archibald. Why appcache is a douchebag, and I'll sum it up a little bit in 4 points. First one: when you visit a site, the files always come straight from the cache. So after the rendering, the browser will look for updates to the manifest and cached files. So you need to reload the page every time to get new files. Second, appcache only updates if the manifest is changed. HTTP already has a caching model, so as a slightly unusual workaround, the browser will only look for updates if the file is listed in the manifest, or if the manifest file itself has changed since the browser last checked. So any change that makes the manifest different byte per byte, that will do. So if you put a space in it, it's fine. It's strange. The app cache is an additional cache. It's not an alternative one. So when the browser updates the application cache, it requests URLs like usually would. It obeys regular caching instructions. So if an item's header says, I'm totally cool until 2022, the browser will assume resource is indeed good until then, and won't trouble the server for any updates. Without specifics, the browser is taking a guess, and we all know what happens when browsers are taking a guess. And files you serves should always have cache headers, especially when they're very likely to be updated. And if you think that's better, just serve with no cache, but always have a header. And the last one is, non-cached resources will not load on a cached page. So if you just cache like the index HTML, but don't cache the background image, it won't be displayed even when you're online. And these are like the seriously super simple pain points of the app cache. There's a solution for that if you still have to work with app cache. There's the appcache nanny. Gregor Martinus, a colleague of mine, taught the appcache some manners and developed the appcache nanny. It helps us to deal with most of the problems the appcache still has, using an iframe for the manifest. So files are served from a server when you're online, and it checks if the manifest is up to date. And there's another silver lining. So you might have heard about the service worker already, which seems to be like the new holy grail of offline first. The service worker is a very specific new web worker. It sounds great, but what is a web worker actually? Most people don't know. So let's take a look at that first. The web worker was introduced with the HTML5 specs, and it's a part of the standard. It runs predefined JavaScript browser scripts in your browser. The support is pretty good, like you can see here. It's supported by all major Okay, wait. Just kidding. Gotcha. Well, this is like the worst case. This is what happens if you're running just too many scripts. Your pace gets super slow, and sometimes scripts even get stopped by after a timeout. It's like the worst case. So sometimes we need to do things like that. For example, loading a huge JSON file, or running a killer algorithm on some numbers, or preload sets of data. Imagine a site that needs to handle like UI events, query some, process some large amounts of API data, and manipulate the DOM. I mean, this is pretty common, right? We all know that. So unfortunately, all of that can't be done at the exact same time due to limitations in browser's JavaScript runtime. Script execution happens within a single thread. So this means a huge front-end logic can block your whole application. And developers love to mimic concurrency. So async events are processed after the current executing script is done. Async but non-blocking doesn't necessarily mean concurrency. Workers utilize thread-like messages passing to achieve parallelism. They're perfect for keeping your UI refreshed, performant, and responsive to the users. So application, you see, it's a very happy one. The moment you need to add a huge task like pulling a huge pile of data, you might run into a timeout. What do you think is a timeout? Like, you know, when popping up, like the script has to be stopped. What is a common thing in the browser, normal timeout? What do you think? Just shout times. In the browser, the timeout for a script. Not the UI, we had that before, for scripts. 30 seconds, 5 seconds, 90. Anyone else? Any guesses? It's 80 milliseconds. Then you should start to use workers. 50 milliseconds is when you, this is kind of common default, and when you're on mobile devices, it's 30 milliseconds. Then you should start using web workers. So the web worker specs defines an API for spawning background scripts in the web application. It allows you to do things like fire up long-running scripts to handle intensive tasks, like oh no, I would say that as soon as the web worker threads runs the code from top to bottom and enter this async phase in which they respond to the events and timers. So you can still interact with your application like you normally would, but outsource the heavy operations. And if they fail and get a timeout, your application is still up and running. Sounds awesome, right? So what can we use the workers for? Encoding and decoding large amounts, large strings. Complex mathematical calculations like prime numbers, encryptions, and simulated annealings, prefetch and or caching data. Cool, right? There's more. Network requests, resulting in data processing, especially processing large areas of huge JSON responses. Calculations and data manipulation on local and session storage. Image manipulations. And can get any better? Yes. Code syntax highlighting or other real-time text analysis like spell checking, real-time search. Analyzing or processing video or audio data, including face and voice recognition, background I/O, and polling web services. I'm sure you found more than 2 things already, right? Who did? More than 2? Yeah. So I guess you found love. I did. And even the sky has limits, so let's take a look what we can and we can't do. First, what we can't do, and it's a lot, or it seems like a lot, we can't access the window object, the document object, and the parent object, so no access to PageScript, globals, or functions. This also means you can't use libraries that depend on the objects to work. Nope, no jQuery or equivalent, sorry. But you can still use those in your UI. This just means you can't use those in your worker. And upcoming React.js version won't rely on the browser, but still, do you really need it? Think about it. So, bummer. What can we actually do? Because web workers have a multi-threaded behavior, we only can access a subset of JavaScript features. The web workers still can access the navigator object, use the read-only location object, execute XML HTTP requests to send HTTP and HTTPS requests. Please keep that in mind for later, we will need that, and set a time or interval for any activity. Access the application cache, we need that for later. Import external scripts, spawn the other workers, we can do that too. So, still lost how we start. Basically, a worker are like these little amazing helpers that you spawn when you can pass them some work to. After they're done, you get back a result. And you can spawn as many workers as you like, but be careful. They do not block your UI, but they can use still a lot of CPU. So basically, freeze it all. I mean, you all know the chaotic minions, workers, how busy they can get. So we have 2 types of workers, dedicated and shared workers. Dedicated web workers are linked to the creator. The creator is the script that called and loaded them. Shared workers are web workers that allow any number of scripts to communicate within a single worker. They are identified in 2 ways, either URL or a explicit name. And normally when articles talk about web workers, it's about dedicated workers. But shared workers are pretty important to us because the service worker are kind of a very specific shared worker. So just a quick look how to start. You need to check if the web worker property in the global window object is available. If not, it will be undefined. They run into isolated threads, so as a result, the code that they execute needs to be contained in a separate file. And you need to create an object in your main script. Constructor takes the name of the work script. So if the specified file exists, the browser will spawn a new thread, which is downloaded, and the worker will not begin until the file completely downloaded, and then it's executed. And if the path to your worker returns as a 404, it will fade silently. Psst, silently. Nice. So, I will put out the slides later. I won't show you the demos because not much time. The only thing you need to know, which is super important, is when you check out like the code, here a lot of examples, which is super amazing. Locally, you need to enable CORS because of security reasons. So we talked about the worker. It's now focused look service worker. The offline first concept became one of the most important ones to follow. We know that already. Jake Archibald got it right the other day. Offline first means getting on screen without a network request. The more that it's there before the network, the more offline first it is. So this means every web application should work without a connection after the very first visit and just use the network to get and set new data. Everything else is online first, sorry. And we all know that appcache is a douchebag. A lot of issues here we need to handle. The major issue with appcache is not just the number of gotchas. The design works really well for single-page web applications, but not for multi-page sites. So, the service worker is a new browser feature that provides event-driven scripts that run independently on web pages. It's a programmable network proxy, allows you to control how network requests from your page are handled and help developers to build like URL-friendly, always available application in a sane and layered way. Oops. But why can't we use the web workers for that? The difference is that service workers, you can fetch your assets and serve them to the caches, so we replace the app cache. On top of that, we outsource the heavy operations, like pulling the huge pile of JSON. Imagine. On your page requests something new. The request gets through the service worker. Then the network, because it's new, and the network serves back the response to the page and to the cache. So, because we told the service worker before to cache to catch the response, it's really great for assets. And here we have the same use case, but the service worker knows we have already stored request asset or data in the cache already, so it serves straight from the cache. So we can add the behavior. It should go to the network and check if there's an update available, and which is awesome. So it saves a lot of time and requests because you're able to control the whole behavior. And one more feature, how it saves resources. Unlike other workers, the worker can be shut down at any end of events. Other workers are just running all the time in the background. The service worker is not. It will be terminated when not in use and restarted when it's next needed. So you can't rely on global state within the service worker on fetch and on message handlers. But if you need to persist and reuse across restarts any informations, service worker have access to the IndexedDB API, so that's fine. Service workers have scriptable caches along with the ability to respond to network requests from certain web pages via script to provide a way for applications to go offline. The main advantages are that service worker doesn't just cache the files. It also supports like background sync and increases your performance enormously and gives you support for push notifications. Service workers make extensive use of promises. You should be familiar with the concept before starting to use service workers. And as the last part of the service worker, I will tell you how the service worker lifecycle works, because it's a really nice insight. To install a service worker from your site, you need to register it, like we've seen before with workers. It will cause the browser to start the service worker install step in the background. Typically, during the install step, you want to cache some static assets. So, if all files are cached successfully, then the service worker becomes installed. And if any of that fails, like the download, the assets, and cache them, the install step will fail silently, and the service worker won't activate, but don't worry about that, we'll try next time. When we installed, the activation step will follow, and this is a great opportunity for you to handle any management of the old caches. After the activation step, the service worker will control all pages that fall under that scope. The page that registered the service worker for the first time won't be controlled until it's loaded again. So, once the service worker is in control, it will be in one of two states. Either it's terminated to save memory, or will handle fetch and message events, which occur when a network request or message is made from your page. Service worker is still in development, but pretty far already. They finally got Safari on the boat, and Edge is developing too. So this is great. And it's partially shipped for Chrome, Edge, Safari. And if you want to dive deeper in service worker, talk by Jack Archibald last year, JSConf.eu. His talks are super fun, legendary, and he's a very amazing guy, so watch that. Link will be online. And there's also the cookbook. So, we have to fast. We have to still take care of one thing, the data. So, finally. First law of robotics is do not harm any humans. do you know what the first law of offline first is? Take a guess. Pretty close, pretty close. Very good. It's do not lose data. This is like the very first law of offline first. We decoupled the client and the server side, so we really need to store it on both sides. Therefore, we trust Pouch for the client and Couch for the server side. They're like a perfect team for offline first. Make it quick and easy. CouchDB is a NoSQL database that replicates, which is exactly what we need for sync. CouchDB comes with a suite of features like on-the-fly document transformation, real-time change notification we rely on with our messages and task system. It also has a very basic version control system, which help us to kind of manage the data. And when your data gets out of sync, it makes kind of intelligent automatic decisions and help you to merge the data. PouchDB is an open source JavaScript database inspired by Couch that is designed to run well within the browser and stores all your data locally while offline. Per default, it uses IndexedDB in Chrome and Firefox, WebSQL for Safari to store the data, and you also can add adapters for local and session storage. It syncs with CouchDB and compatible servers, which speeds the CouchDB replication protocol, like CloudInt or Couchbase Sync Gateway, when the application is back online. It also works on mobile devices for native applications, for example, with PhoneGap, Cordova, and many, many more. The special thing about Hoodie is that every user has their own private database, like I mentioned before, and it's private by default, so we solve a lot of problems from the get-go. When we have one database per user, we always know where to sync to. When the version of the document isn't up to date, we can check by appcache document version ID, which to sync first and how to merge the data without real conflicts. When we receive partial data, we store the version of the document and can grab that before merging. And thanks to the event listeners and tasks, we can sync the data across devices. So this means we have multi-device usage on the fly. If you want to share the data, sure. When you want to share some private data, you can publish it and it gets just replicated. And others can read and manipulate the data. And we are able to sync it again in our application logic into the private storages. PouchDB is also a CouchDB client, and you are able to switch between a local database and an online CouchDB instance without changing any of the application code. So, a question I get asked a lot: how much data can PouchDB store? So, I prepared something nice. In Firefox, PouchDB uses IndexedDB, which will ask you if data can be stored. First time it is attempted, then after 50 MB every time stored, the amount of data can be stored is unlimited. Chrome, very cool, calculates the amount of your available storage on the hard drive and uses that to calculate the limits. Opera works the same as Chrome because Blink. Internet Explorer above 10, hard 250, below, don't talk about that. Mobile Safari, IIS, hard 50, desktop Safari, prompt more than when you want to store more than 5 up to 500 MB. Android, same as Chrome, 4.4 and above, older, hard 200. And Photo Cordova, unlimited on both iOS and Android by using the SQLite plugin. So, a lot of information. I hope I could give you a small insight in the concept of offline first and how to build applications that handle offline first, not as a bug, but it's a feature actually. And if you'd like to say hi or grab some hoodie stickers, I have some here. So I'll be around. So thank you very much.